All right, module 5.2, we are looking at the principles of systems. And now we're going to turn to systems models. In part of the systems thinking, we talked about that conceptual models that let you frame up complex systems would be quite useful. So that's what we're going to look at in this little module, in this little lecture. All right, let's just remind ourselves that human civilization, wherever it is, if we're talking about the Neolithic people living on Orkney, building their monuments and their villages and that sort of thing, human civilization is always complex. There's nothing primitive or simple about the way humans organize themselves. All right, so people always have their way, right? Every society in every place throughout history has had their way of doing things. It's just in the DNA of humanity. People are very connected to place, and they know very well the resources in their place. As far as we can tell, humanity has used energy in like forever. As long as Homo sapiens have been around, and Neanderthals also used energy. If you cook food, if you gather wood and you can make fire, then you can, it opens up a lot more nutrition, and of course, kills a lot of pathogens if you cook over a high heat. So it really helped our survival to make friends with energy. We also use materials. We have our own technology, the kind of buildings that are built, the infrastructure that's used, the way people get around. Just look at any society that we've ever known in any place, and you'll see that each has their own way of doing these things. Also, the connections between people. You can characterize what the collective government looks like, and what that collective government does. For most of human history, that has been a hereditary monarchy sort of thing, or a theocracy, or a monarchy that also your monarch is your god. That works pretty well, consolidates power. You don't have to have public school to have education. Civilizations always have education of the young. Education of the young to do what? To be them, to carry on what's been going on. There's always trade. As far back as any archaeology has ever uncovered, there is no such thing as a isolated, self-sufficient society. That's just not a thing. We always have trade. And looks like there's always been business. Now, what does business really mean? It means that somebody gets good at something, and therefore their labor has value to others, because they can make a thing well. And so you have division of labor, and that's basically the essential building block of business. All right, so that being said, what does a civilization look like? So here's the players in the civilization, the elements of the system. The system, if we lay it out, this complex human system that we're talking about, here's a model that we can use. Right in the very middle, you see the word sleep. Okay. Large brain primates like ourselves need to nest. We have a large brain. A lot of the energy that we take in, a lot of our food goes to operating that brain. It's what's keeping us alive. It's what deals with the complexity of our system and our environment. It's what lets us plan ahead. It's what lets us know our culture. All right, so we've got this big brain. That big brain has to sleep. And when we sleep, we get deep into sleep. We don't sleep like dogs. We're not easily awoken. And so we always build a place that's safe. We bring together our group, our family, our close, trusted individuals, into the place where we sleep, and we normally call that home. Now, in the home, you have to have access to energy, that fuel for cooking. You prepare meals there. It gives you shelter from the elements. It is the place where caregiving is given. In human society, you always have, 30% of the population actually can't take care of itself. It needs the nurturing and care of the others. So the caregiving is there. There always has to be some kind of sanitation, washing, a way to get rid of wastes. And that home has to have access to primary resources and to water. Also, for most generations of humanity, that home also had a garden. It had a local access to cultivated sources of food. So there you go. That's the center of everything: access to food, fuels, water, and primary resources and materials. Stones for making flint, clays for making pots, reeds and fibers for making clothing, etc. All right. Now, that's where we spend the night, and we need access. So these funny little lines represent access to other things. Now, we also need access to production. So we have to go make things. We have to do things. So this is what we now call our job. So we often leave the house, or maybe we don't go too far. Maybe we can do a lot of our job where we are. So farming, fishing, often very connected to the house. Manufacturing, processing, mining, producing energy. So in days gone by, maybe this was the woodcutter or the charcoal maker. And then, of course, we have to have access to trade. And that trade, we may not be doing it in particular, but there will be a system then through which trade happens. So our community has to have access to trade. Our community also has social and cultural activities that we need to be able to access, and it has market activities and people getting together, doing things together and having feasts together, etc. And we also need access to the natural environment. We just do for recreation, leisure, communing with nature. We also have services that we need to have access to. So our governance, medical services, societies always have a justice system, the old Orcadian system and Norse system of the Ting. There's just always been a justice system and a security system. So sort of police or a night watchman, or the sheriff, right? So essentially, I have been jumping around through different types of civilizations in different times, but you can see how this model sort of encapsulates that. Just any civilization we could map out this way. Now, there's also some things here that aren't denoted in the little boxes, because infrastructure is part of the access to things. So infrastructure of a well gives you access to water. Infrastructure of a dock gives you access to fishing, to primary production. Access to a river might give you manufacturing energy through a water wheel. All right, so infrastructure is very important. Moving back and forth, transport. You might have paths, you might have roads, you might have rail, but that being able to move things and people is always a key element of society. The technology that people are using at any given time could be all sorts of things, but whatever that technology package is, this society has to have access to it. If you imagine that all of a sudden a society in the 1200s completely lost the ability to make pottery, things wouldn't go all that well. So we need our access to the technologies that we have and the knowledge of how to use them. And the built environment. So that's the houses, aqueducts, roads, just everything that is built, the furnitures, etc. All right, so this model really should be able to cover just about any civilization and point up what's actually essential. Remember, we have to turn things around to look at the essential activities, so we can use this map to sort of figure out what kind of essential activities we're looking at. All right. There's different ways to look at a system, from the top down, from the bottom up, or where the two meet in the middle. So let's think about that for a minute, because this little way of characterizing things might be useful. From the top down, and also remembering that there isn't just one way to look at things. Remember, one of the competencies that was important was being able to look at things different ways, from different perspectives. So the top-down perspective is international agreements, our government's policy, our infrastructure, our power supply, our fuels, right? Those are things that we don't do for ourselves. They're done centrally, produced by big corporations, and they're sort of top-down things. So from the top down, we have targets, policies, infrastructure. The government produces scenarios and pathways to form its thinking or something. It can create incentives to try and nudge different things to happen. And of course, it collects taxes to do its work. So that's the top down. From the bottom up, we're talking about communities, people in places, the values that people have, the enterprises that people get up to, the work that they do, also the caregiving that they do, and the way that they organize themselves and their organizations. So our ground up activities are meeting our needs, being resilient, carrying out work that makes us resilient, understanding is this system, how does it perform? So the well-being of people, affordability, access, adaptive capacity, and what are we going to do next? So up here we've got pathways and scenarios, and down here we've got, okay, what are we going to decide to do and do next here in our community? Now in the middle here, I've put some things, training and skills, like those are, our education system is usually a place where the bottom up meets the top down. Technology and built environment, government often funds research into new technologies. It often funds big builds in the built environment, social housing, for example. Behavior and society, like we said, government often tries to manage behavior in society, and people in the communities are just doing what they know how to do. And of course, research and development and finance is sort of where the activities from the bottom up or from the ground up meet the governance of the top down. So we can see if that little model helps to get our head around things. That's a structural model. Remember, we were looking at being able to understand the structure of things. Now, we keep saying that our systems are complex. So one way to deal with complexity is to sort of characterize things that are like each other and then put them in a cross-cutting relationship structure. So this is what we've got here. That sort of model of the society, let's put that here, our place. Where's our place in the world? What's the nature? And the biocapacity reserve sort of means like all the things that are not human, but that, you know, that the part of the world that we don't use directly, that we're, you know, not our farms, but all of the rest of nature. And we know that environmental biocapacity reserve is key to keeping everything working. Our social capacity within our civilization, and our economic capacity, our ability to behave in ways with each other that make the whole system work. That's what I'm going to call economic capacity. We talked about top down and ground up, And so if we look at from the ground up, we've got our houses and our buildings, our built environment, and we've got our trade. So the the goods that we all use, and those move about by ferries and flights, and they use ports and airports. And then our ability to access things, so personal and freight land transport, vehicles and infrastructure. We have to make things. I mean, with our manufacturing and processing, our extraction, and even like our museums and monuments and national parks. So we create these things and use them. Oops, this way. And our primary production. So this is use of the land and the water and the natural environment, farming, fishing. All right. So all of these systems, or all of these elements of the system, I should say, today use fossil fuels. So that is a big chunk of what enables these systems to work the way that they do now. Electricity is another big input into the system. Governance, so we always have rules and regulations, and the way things work, the way things are financed. So governance can be government, but also insurance, finance, even educational governance, that sort of thing. And then assets are our built environment, that is that access between things. So our sewer system, our water system, our transport systems. All right, so this little model also is a way to understand the structure of our complex system. And this model and the top down, bottom up, and the essential activity, you might have noticed that each of these is, I could take a snapshot, I could take a picture at any given time of a system and map it out and organize it and understand it this way. So it's a snapshot in time. Systems are also dynamic. They're moving along in real time, and things are happening every day, and things are changing. And so we need a dynamic model. So this is going to be our Anthropogenic System Dynamics model. It's a model of those same things we just took snapshots of, but now how do they actually operate in time? And in order to talk about a dynamic system, you have to know the purpose of the dynamic system, like what's it supposed to be doing. If it's an airplane, it's supposed to be flying, but not just flying, it's supposed to take off safely, fly, and land safely. So what's the purpose of the system? And if we're talking about an anthropogenic system, that just means a human system. The purpose of the system, like what's the point, is survival. And just survival isn't really the point either. We really want, well, we must survive. So we know that. That's imperative. That's essential. But it's necessary that we also thrive. So we're going to do whatever it takes for life to be good. So we're looking to continue to exist and for life to be good, right? So again, which people aren't driven by that? Everybody is. That's basically humanity. Now, at any given time, in any given place, any given culture, the lens through which we understand what our survival means, like what do we think we have to do in order to survive? That will really depend on our cultural vision, our beliefs, our values, our paradigms. There's cultures that reckon once a year they need to make a sacrifice to the gods, into the sacred well. I don't know. There's lots of ways that we see the world, and we come to understand how it is, what we need to do to survive. So there's always this sort of lens that translates survival into some picture of what survival would look like to us in our way. All right, then excuse me. Then that and these little arrows are not flows of things, they're more signals or ideas or imperatives. All right, so they're signals if it was an electronic system, but they're ideas, communications, signals. So there's our belief in what we look like when we are doing well and surviving, and we're going to be okay. And that is then, now there's another lens, which is our behavior. So here's our view, our vision, our paradigms, and here's what we do. So what we believe and what we do. So what we do, we've definitely got habits. We do the same thing over and over. We're very habitual. We have patterns in which we go about our lives, and that's basically our behavior controller here. So this is kind of a controller on what we do, as what our vision is and what our beliefs are. And of course, there's a top-down control on our behavior and our habits and our patterns, and that is the experience that we have from doing this before, right? So that's the biggest controller, actually, is what has worked before is what we will do again. So that's a big controller. Education, right? If we learn something new, that might affect our behavior. And our governance or rules and regulations, we will mostly follow those. That's the way we decide what we're going to do. Now, day to day, the activities are carried out given all of that filtering. And these activities require us to interact. So we interact with the built environment, and we interact with the goods and services in the built environment, and that is basically economics. So economics is how we interact with a system. Now, even if you say, well, okay, people have only had paper money for so long, right? So economics, but that economics today uses paper money, but economics doesn't have to involve money. And there's really good historical understanding of that. If you look, say, 1700s, there was money and there were things that required money, that's for sure. But there was a whole economy that didn't work on money. It worked on obligation. It worked on giving. It worked on helping each other, and doing like for like. So people might get together and help the family that had a big flax farm. People would come together to do the thrashing of the flax, and then they might be entitled to some share of that, right? So coming together, doing things in a way that is definitely accounted, but it's not just a monetary transaction. So don't forget about that. That a lot of civilizations around the world don't do everything based on money. Then we've got our built environment. So our shops, our schools, our houses, our buildings. So this is what you would see if you looked down from a satellite. What's going on? What goods have we got? What's being manufactured? And of course, it's this activity here that requires resources. So far, it's all just been thought processes and behaviors. But when we start to engage in economic activities, that's when we start to consume, right? So we're using resources, we're building things, and our activities produce impact. So this is the world around us, that biocapacity, minerals, wood, forests, etc. So the performance of our system, what would the performance be? The performance indicators and the implications of that performance. Well, the performance is that we are surviving and thriving, or we're not, right? So if we can take a look at our way, we have ways of understanding how it's going, and we evaluate that and we say, okay, how is it going? So annual festivals where we look at the harvest and we evaluate. These things are built into civilization, really built into culture. How's it going? Is our way working? And if we have a sustainable way of doing things, then the answer would likely be yes, our way is working. We are managing our risks. We really don't want to change anything because it's riskier to be changing things than it is to be staying a steady course and doing what we traditionally do, doing what fits our culture and our rules and our norms. All right. However, if the feedback says that no, something's going wrong, we can't continue the way we are, there's a lot of risks, the risks of unsustainability, we aren't going to be able to continue, and these unsustainability risks, they might be that we don't have access to resources, or the impacts are too great. We can't keep this thing going. It's not going to keep working. And so when that happens, then there needs to be changes in this system. Now, what are those changes? Well, that's where we need the systems thinking. We need the bright ideas and the analysis to understand, if we made certain changes, how would that affect the system, and how would that affect our use of resources and impacts, and therefore give us that effect that, okay, we're going to be fine, it'll work. When we make changes in the built environment, it will cause changes in behavior. Okay, so our behaviors, in fact, are in the context of the built environment. So, like we said, our experience of what worked before, that was in the context of that built environment. If you went from Kenya to Argentina, the built environment would be different, and the behaviors would make sense within that context. All right. So we're also going to need new rules. So this new change in the built environment is going to stimulate new rules in order to keep the interactions and the operations working. All right. So that's sort of a dynamic model of how over time the system would work. We can frame it up without the cartoon people, and look in relation to the structure, that snapshot structure that I gave about complex systems. We can just map out that dynamic operation in terms of that. So those 6 basic characterizations of the built environment all fit in here. The external resources, the capacity and reserves, the energy, and of course the impacts on that environment all fit in here. And then our experiences, our education, our governance, that's sort of the governance over the behaviors and patterns here. What we think is that transition engineering is that work of figuring out how we need to change the system because of feedback about what's unsustainable. And that change needs to directly inform and cause changes in behavior that fit with the new change in the built environment, so that very quickly people can learn the new pattern and adapt and fit into the new behavior. All right. So this is pretty exciting. We've got a model of how to do all this this change and how it works in a dynamic system model. The punchline of this model is that transition engineering, you notice what it doesn't do. It doesn't have to change our governance. The governance will change as the system changes. It doesn't just say, let's change behavior. Behavior will change as the system changes. So it's about the built environment system and the interaction of that system with the resources and the impacts. Okay. All right. That's good news, actually, because this is all engineered, the engineered system. So we're going to work on the engineered system. Good news.